Hello and welcome to the mini test solving for the lecture 27 integration rule mini test. So the lecture was slightly longer than I wanted it, but I presented everything in under an hour, so I'm proud of myself. But then again, losing time means losing some context, and hopefully that didn't deprive you of information. But anyway, here's the mini test for those of you who came to solve it, and let's get right ahead into it. So our problem is a three-term chain. So three different functions added together. So let's use the sum rule and break this into a sum of three integrals. Now let's get our table for each of them. So they're in a funky order. And I will simplify by using the constant product rule because 4, 6, and 2 are constants. I'll carry the constants multiplied to the functions outside of the integrals. And of course, color code them so it's easier to follow what I have done with which. So yellow is the normal power one. The purple pinkish is the 1 to the power x to the power minus 1, 1, and orange is the e to the power of x. And now I'll reorder these guys so they actually fit closer to whatever we're working with. I will, so I apply this rule to this one, I get this, apply this rule to this one, I get this and this. We get three constants, but again, it's a constant. 5 plus 3 plus 8, it's like C1 plus C2 plus C3. We get a C4, not the explosive one, but another constant in itself. So I'm just going to combine all of them into one C, because technically this is one integral we're starting. We don't need too many constants to not overcomplicate everything. But yes, now we just simplify stuff further. 4 gets cancelled out by 4, and we're left with x to the power of 4 plus 6, natural logarithm of absolute value of x plus 2 times e to the power of x plus c as our result to this integration. Fancy, right? Exactly. For this one, because there are no brackets, we need to solve top-down, as I clarified. So start solving with the topmost exponent and solve it down. So the very top value is the exponent to the one under, solve that, that becomes the exponent to the number under, etc. This technically follows PEMDAS or BOMDAS rule, so the priority rule. And since exponents have priority, so the higher the exponent, technically the higher the priority, you solve the ones that are like on the outside. I don't know. That's how it is, since there isn't a bracket over the base of the first exponent. So we have a product of two functions, where one of them has another function inserted, and I see that the insert and the other function are in a sort of relationship where where the one on the outside seems like a derivative of the one on the inside. So this means we're using the U substitution. We get the formula for it, and I pretty much already ordered it in the correct order. So we see that whatever is on the insert is labeled as u, and the rest is du. So our u will be x to the power of 3. We take the derivative, we get 3x squared, and now we have to find a way to get this equation into a x squared times dx on one side. We get that by multiplying with dx and dividing with 3. So we get something like this. And then we replace this part in this formula with this part. And we just replace that. Also, we replace the x to the power of 3 with u. We're getting this formula, and we get, using the constant multiple rule, we move that constant multiplying factor outside of the integral. We solve the integral with the rule which we probably know by now, but if not, it's here. So e to the power of some constant times the differential of that constant is the e to the power of that constant plus c. So we get 1/3 times e to the power of u plus c. X to the power 3 is inserted instead of u, and we get our result of 1/3 times e to the power of x cubed plus c. This is a relatively simple example. I think that the more I speak, the more complicated it gets. I hope that's not the case. If it is, please comment and tell me down below. I'm gonna stop talking so much. And as for the last problem, we have a product of two functions. So we're gonna use the integration by parts, because I can't find one in the relation to the other being the integrated one. So going down the Liate rule, logarithms, inverse, trig, algebraic, trig, and exponents, we see that x is algebraic and it's before trig, because a is before t. So x will be u, the rest will be dv. And technically we have, okay, never, yeah, that's fine. Of course, we could use the tabular method here, but since that one is sort of easier and I didn't really cover it in the video, I'll rather use the long way. So for those of you using the long way that I'm using, so yeah. Anyway, So differentiating the x, so to get du gives us 1. Du over dx is 1. And we carry the dx over, du equals dx. So we have our du and u. Now the rest of it, so if this is labeled as u, the rest of this has to be dv for the formula. So like something like this, I guess. Yes. So the rest is dv, and then we have to integrate that. Following the rule in the top, we get that our v is sine of x. Now that we have all 4 parts, we insert them into our formula. I color code again. So the green goes here. So here, u becomes x, dv becomes cosine x dx, and we get our original integral. And that one equals to u times v, so x times sine of x, minus integral of sine of x times dx. So like this. And now we solve what we have on the right. So for that we need our table rule, and we know that integrating sine of x dx, we get minus cosine x plus c. So we insert that in. Minus minus makes a plus. So we get x sine of x plus cosine of x plus c, because, well, we like to stay positive, and it doesn't matter what the sign in front of the c here is, because we're not solving for it, and even if we were, original function would have the same value, just corrected for the signs. Anyway, this was it for the mini test. I hope everything was clear. I hope everything was not problematic. And if it was difficult, then that means you're learning something. Thank you so much for tuning in, and I'll see you all next time. Bye!